Hello everyone, in this video we're going to find the maximum value of this expression if it's given this system of equations. Let's start. First of all, let me rewrite these two equations as it is here. So x minus y plus z minus 1 is equal to 0, and xy plus 2z squared minus 6z and plus 1 is equal to 0. So I'm going to rearrange each equation. So here I'm going to move this x and y to the right hand side and these terms to the right hand side. Then this equation is equivalent to y minus x is equal to z minus 1, and xy is equal to minus 2z squared and plus 6z and minus 1. Now let me label each equation. So this is the first equation, this is the second equation. So I'm gonna square the first equation. So if I square the first equation, then I will get y minus x to the power of 2 is equal to z minus 1 to the power of 2. And for the second equation, I'm gonna multiply both sides, then I will get 4xy is equal to minus 8z squared plus 24z and minus 4. Now again, let me label each equation. So this is the equation number 3 and this one is equation number 4. Now I'm gonna add equation number 3 and equation number 4. Then I will get y minus x to the power of 2 plus 4xy is equal to z minus 1 to the power of 2 and minus 8z squared plus 24z and minus 4. Now let me analyze the left hand side of the last equation. So let me rewrite here y minus x to the power of 2 plus 4xy. Now if I square the first expression, then I will get y squared minus 2xy plus x squared and plus 4xy, and which is equivalent to y squared plus 2xy plus x squared, and which is equal to y plus x to the power of 2, and which one is always greater or equal than 0, and which means that y minus x to the power of 2 plus 4xy is always, so let me write here, plus 4xy is always greater or equal than 0, and which means that in this equation, if the left hand side is always greater or equal than 0, then the right hand side also must be greater or equal than 0. So therefore, let me write here. So then the right hand side is, let me write here, z minus 1 to the power of 2 and minus 8z squared plus 24z and minus 4 must be greater or equal than 0. Let me now solve this inequality. So first let me square the first expression, z squared minus 2z plus 1 minus 8z squared and plus 24z minus 4 greater or equal than 0. Now minus 7z squared plus 22z and minus 3 greater or equal than 0. Now let me move all terms to the right hand side, then I will get 7z squared minus 22z and plus 3 less or equal than 0. Now to solve this inequality, I'm gonna find the zeros. So here the zeros are z1 is equal to 3 and z2 is equal to 1 over 7 and 1 over 7 here. And so therefore the left hand side can be factored as 7 times z minus 3 and times z minus 1 over 7, and which one is less or equal than 0. So let me draw here number line. So in the number line here 1 over 7 and here 3, and in this interval, so let me here write the interval. So from minus infinity up to 1 over 7. So and from 1 over 7 up to 3, and from 3 up to plus infinity. And let's analyze the first interval. At this interval, let me write here, this is going to be positive, so therefore this one is plus. So this is going to be minus and this one is plus. So therefore our answer is x belongs to from 1 over 7 up to 3. Or an inequality form, x lies between 1 over 7 and, sorry, not x here, sorry. So here z, sorry for that. So z belongs to, so 1 over 7 up to 3. So therefore, an inequality form, z lies between 1 over 7 and 3. Now, knowing this, now let me back to our original question. As you remember, we are looking for the maximum value of x minus 1 to the power of 2 plus y plus 1 to the power of 2. So therefore, let me now here rewrite this expression here. So x minus 1 to the power of 2 plus y plus 1 to the power of 2. Now let me here square both expressions. So x squared minus 2x and plus 1 plus y squared plus 2y and plus 1. Now let me rearrange this as follow. X squared, so here let me write like this, y squared minus 2xy and plus x squared, and I have to here write plus 2xy, and also so here plus 2. If I factor out from these two expressions 2, then here y minus x and plus 2. And as you can see here, this is going to be equivalent to, so this one is perfect square, y minus x to the power of 2 and plus, so here 2xy and plus 2 times y minus x and plus 2. But as you remember, we already said that y minus x is equal to z minus 1 and xy is equal to, let me show it here. So as you remember, y minus x was z minus 1 and xy was minus 2z squared plus 6z minus 1. So therefore, let me plug into these two expressions. So therefore, this, since this one is z minus 1 and this one is, so minus 2z squared and plus 6z minus 1, and this one is z minus 1. So therefore, let me plug it. So this is going to be equivalent to z minus 1 to the power of 2 and plus 2 times minus 2z squared plus 6z minus 1 and plus, so 2 times z minus 1 and plus 2. Now this is going to be equivalent to, so let me here first square the first expression, z squared minus 2z plus 1 and minus 4z squared plus 12z minus 2 and plus 2z minus 2 plus 2. And this is going to be equivalent to, here this is going to be cancelled and this is also going to be cancelled, and minus 3z squared and plus, so here 12z and minus 1. So we see that, as we remember, z lies between 1 over 7 and 3. So therefore, at z is equal to 2, if z is equal to 2, then our x minus 1 to the power of 2 plus y plus 1 to the power of 2 will be maximized. So therefore, this is going to be equivalent to, here, minus 3 times 4 and plus, so 24 minus 1, and which is equal to 11. So this is our final answer. Thank you for watching. Please comment and subscribe to my YouTube channel.